Okay, so in this chapter so far, we've looked at problems that have no solutions, right? And we looked at solving systems of equations. Sometimes when you solve systems of equations by graphing, there's no solutions, right? So what are the methods we've looked at so far? The methods for solving, systems of equations. What was the very first method that I really taught you? Graphing. Alright, so in the graphing method, how did you know that you had no solutions? And how do you know when you have one solution and when you have infinitely many solutions? Y'all remember? When you're graphing equations, if the two lines are parallel, they do not share a point, so that means what? No solution. Alright, what happens if you graph them and they cross at one point? That point right there means that you have one solution. And then in graphing, when there's infinitely many solutions is when you graph one equation and then you graph the second one and it's right on top of it. So if you graph two equations, they fall right on top of each other. That means that there's infinitely what? Many solutions. Okay, so when we solved these by our second method, which was substitution, right, how did we know that there's one solution? Well, we get x is equal to a value, y is equal to a value, right? We can actually solve it. But how did we know that there was no solution when we did the substitution method? What happened to your variables? Your variables canceled out, and your resulting equation, whatever the equation was that you were left with, your resulting, your resulting equation was what? False. Alright? How did you know that there was infinitely many solutions when we used substitution? Infinitely many solutions. What happened? First of all, your variables canceled. So they canceled out. And then the next thing was the resulting equation, whatever equation you had left over, was what? True. Was true. So an example of that is if you got something like 3 was equal to 3. Right? So if your equation was false, like 6 is equal to a negative 3. See how that's false? That means that there is no solution. Well, what we're going to look at today is what does it look like in the elimination method? How do we know when we have no solution? And how do you know when you have infinitely many solutions? What do you think? If you had to take a guess, what would you say it would be? Anybody want to take a stab at it, what you think it would be?
No solution or like no y or x.
Okay, it's a good guess. So kind of like this one. The variables disappeared and the equation was false. It's no solution. If your variables cancel out, right, and then your resulting equation is true, it's infinitely many. So it's really the same rule as substitution. Okay, it's going to be the same thing, and I'll show you why in your notes. In problem 5 in your notes, all right, what if we're just solving this system right here? Solve that system. Okay, how many solutions does the system have? Well, let's just solve it. Right? So in this problem, are any of my coefficients the same? No. The numbers in front of the variables are not the same. So can we make them to become the same? All right? So that way I can eliminate one of them. So do you want to eliminate the x's or do you want to eliminate the y's? Which one would have, or I guess it's basically the same amount of work for both. So just pick one that you want to eliminate. You want to eliminate the x, right? So I got to get these both to have a coefficient of what? 2, right? That's got a 2. Can you make that become a 2? How? Multiply it by 2. So I didn't mess with the top equation, so that's 2x plus 6y is equal to 18. Right? But on the bottom equation, if you multiply it by 2, I get 2x. What's 2 times 3? 6y is equal to 2 times 9 is 18. And then what do I do with those equations? Subtract them, right? So because it's the same signs, right? If the signs are the same, you just subtract them. So I take 2x minus 2x, which is 0. 6y minus a positive 6y is 0. 18 minus an 18 is 0. My variables canceled out, and what is the resulting equation that's left over? 0 is equal to 0. Is that true, or is that false? That's a true statement. So what happened? My variables canceled out, and my resulting equation is what? So what does that mean? It means that these two equations, and you can look at it, are identical. So that means if I were to graph them, they're going to fall right on top of each other, which means that they have how many points that they share in common? Infinitely many. So this is exactly the same way as substitution. So what is this? How many solutions does this have? This has infinitely many solutions. Do you understand that? So it's really exactly the same as substitution, no difference. So let's look at problem 5. Finding the number of solutions this one has. Okay? How many solutions does this have? Well, let's just solve it, right? Well, look, my coefficients are the same, my coefficients are the same, so what do I do with these two? Right, I don't have to manipulate the equations. I don't have to rewrite it if I have the coefficients the same. What do I do? Do I add them or do I subtract them? I would subtract these two. Now, I could just subtract from top to bottom, or I could use my subtraction rule by adding what? The opposite, the opposite, the opposite of each of those bottom numbers, and then just combine them. A negative 2x plus a 2x is 0. A 5x plus a negative 5, or excuse me, a 5y plus a negative 5y is what? 0. 7 plus a negative 12. What's 7 plus a negative 12? A negative 5. So I get 0 is equal to negative 5. So my variables canceled out. Is my resulting equation true or false? It's false. So what does that mean? Just like in substitution, if my variables canceled out and my answer is false, it would be no solution. So it's the same thing as the substitution method. If your variables cancel out and the resulting equation is false, then what? There is no solution. So what does that mean it would look like if you were to graph it? What does that mean it's going to look like if I were to graph? If I were to graph these two equations, what would it be? Two lines that are parallel. They have the same slope but different y-intercepts. Okay? All right, let's just see if you understand the lesson. I got a couple problems to do. All right? So here's example 1. All right, solve that using elimination. So give yourself a little bit of time and kind of decide which one do you want to eliminate. Do you want to get rid of the x's or do you want to get rid of the y's? What do you think you'd want to get rid of in this problem? Y's? Okay, so I've got to get these numbers to be the same numbers, right? I don't worry about the signs. This could be a negative, this can be a positive. Just don't worry about the signs. So I just think of that as the absolute value of a negative 2, which is 2. Right, and that's a 3. So what's the least common multiple of 2 and 3? 6. So make that become a 6. How do you make that become a 6? You can only multiply it, so multiply it by what? 3. That whole equation by 3. How do you get this one to become a 6? Multiply the whole equation by 2. And then what's your new equation, or your new system? 3 times 3x would be? 3 times a negative 2y is? Negative 6y. And then 3 times a 1 is 3. What's my next equation going to be? 16x. 2 times a positive 3 is a positive 6y. 2 times 2 is 4. Now, what do you do with those two equations? Add them or subtract them? If the signs are different on those coefficients that you're trying to eliminate, you add them. So take 9x plus 16x, which is 20 what? Isn't it 25? 25x? Is that right? 9 plus 6 is 15, or carry the 1, get 25x. And then negative 6 plus a positive 6y is 0, so that's like plus 0 is equal to 7. So I get 25x is equal to 7, so what is x? Yeah, divide by 25, divide by 25, and just leave it as a fraction. 7/25. Okay? So now that I know what x is, how do I figure out what y is? Plug that x into either the top equation or the bottom equation. Which one? Top? So I'm going to take 3x minus 2y is equal to 1, and wherever you see an x, what are you going to plug in? 7/25. So it's 3 times 7/25 minus 2y is equal to 1. So what's 3 times 7/25? Well, if you want to do it pencil and paper, that's fine. Or we've got technology, so just use your calculator. So it's 3 times, in parentheses, 7 divided by 25 is 7/25. Everybody understand how to put that in there? So I get 0.84. Let's change it to a fraction, right, since our other one's a fraction. So hit math, frac, right, which is math 1, and then enter. Bless you. So it's 21/25 minus 2y is equal to 1. Right, what do I do now to get the y by itself? I got to get constants on one side, variables on the other. That's a constant, that's a variable, because it has a letter attached to it. So let's move this over here. When it jumps across, it becomes a negative 21/25, and it's not there anymore, so I'm left with negative 2y is equal to, what is 1 minus 21/25? When I put this in my calculator, I put it in parentheses. 21 divided by 25. It's just a good habit to put fractions in parentheses. Okay? Hit enter, and what do you get? 0.16, which is what is a fraction? 4/25. Alright, so how do I get y by itself? Divided by negative 2. So what's y? Well, let's take that 4/25, and since that was the last answer in my calculator, I can just hit divided by, because I'm dividing it, and it's just taking the last answer, which is 4/25, and dividing by negative 2. So hit enter, and then change that to a fraction by hitting math 1, enter. So it's negative 2/25. So what's my solution to this? Write it as an ordered pair. 7/25 and negative 2 what? 25. So fractions shouldn't be hard to do because we can plug those in our calculator. Alright, let's look at 2. Alright, how do I solve 2? Well, I mean, you use the same process, right? Try to get the coefficients to be the same. Look, the coefficient this time is an A and an A. Are those the same? Is it 4 A's? Right? That's a 1A, that's a 4A, they're not the same. But look at this Y. That's the same as this, isn't it? So that's like a positive 1, that's like a negative 1. So if it's the same coefficient but different signs, what do you do with those two? Add them. So let's add those two equations together. What is an A that, remember, that's like a 1A plus a 4A. What's 1A plus 4A? That's 5A. So think of that as, that's your coefficient, 5A x. And then what's a positive 1y plus a negative 1y? So that's like plus 0 is equal to 18 plus 12, which is 30. So I get really 5ax is equal to 30. So what's x? Well, to solve it, to get x by itself, you just divide by 5/8. See, if I knew that was like a 7 or a 10 or a 15, right? I don't know what a is, right? So I'm just dividing by 5 times whatever a is. So that's like my coefficient. So 5a divided by 5a is 1, right? And 1 times x is x. But remember, what you do to one side of the equation, you got to do the same thing to the other side. So this would be 30 over 5 times a. And that reduces, doesn't it? What number will go into 30 that will also go into 5 times a? 5 will, right? 30 divided by 5 is 6. And then 5 divided by 5 is 1a. So this is just 6 over 1 times a is a. So there's my x. How do I figure out what y is? Well, I take that x value and I plug it into either the top equation or the bottom equation. Okay? So pick an equation that looks easy to deal with. Probably the top one. That was a times x plus y was equal to 18. Wasn't that my original equation? What is the value of x? 6 over a. Alright, so this is the same thing as a times x plus y is equal to 18. And what is the value of x? 6 over a. So if I multiply those two together, remember this is like a over 1, right? So multiply fractions, that's like a whole number times a fraction. Make that to a fraction, and then just take tops times tops over the bottom times the bottom. Alright? So what is 6a divided by 1a? Remember, these have a common factor of an a, right? So I can divide this by a. And I can divide this by a. Or I can think of it as an a divided by an a is a 1. The same thing, right? So this is really just a 6. 6 plus y is equal to 18. Because a divided by a is the same thing as 1. So how do I get the y by itself? Subtract 6, subtract 6, so y is equal to 18 minus 6 is 12. So what's my solution to this? What is x? 6 over a. And what is y? 12. That's a little bit more of a confusing problem. I don't think you'll see one like that on the ELC. Alright, so your homework today is to do Math Excel. Okay? It's 4-3. It should already be assigned to you. We have plenty of time in class to get this started. So go ahead and grab a Chromebook and we'll get started on Math Excel.